So there's this storm, Typhoon Kalmaegi, that's just ripped through the Philippines. And guess what? It's not over yet. But here's the crazy part. This wasn't even the strongest typhoon we've seen this year, not by a long shot. So how in the world is it shaping up to be the deadliest? Well, that's what we're going to get into. We're going to break down the anatomy of this killer storm.
Okay, let's just start with this number, 140. It's a stark figure, and it represents the human cost of this thing right off the bat.
And you have to remember, every single one of those numbers, that's a person, a life lost in the Philippines. And what's really tough is that number, it's probably going to go up. There are still over 100 people missing, a lot of them from the province that got hit the absolute hardest, Cebu. Now this is the part that's kind of wild. Kalmaegi, it wasn't the big bad wolf of the typhoon season when you look at wind speed. So it really makes you wonder, right? How did this storm become the most lethal? That's the puzzle we're going to solve together. All right, first up, let's dive into what happened in the Philippines. Because the scale of this catastrophe is just massive. It's all about the human cost of a storm that took its sweet time. For a place like Cebu, this wasn't about the wind. No, this was a deluge. We're talking about a flood of almost biblical proportions. I mean, just look at these numbers. They're staggering. We're talking way beyond the tragic loss of life. Over 1.1 million people were affected in some way. Think about that. Over 500,000 had to leave their homes. 450,000 people crammed into evacuation centers. And get this, 1.4 million households lost power. That's not just a storm, that's a total system shock. So the big question is, why Cebu? What made it ground zero for this tragedy? Well, it was like a perfect storm of terrible factors, all hitting at once. First, the rain. You're not going to believe this. A month and a half's worth of rain fell in a single day. That unleashed flash floods that just blindsided everyone. And then you have the geography. The rugged terrain basically acted like a giant funnel, pouring all that water straight into towns and villages. And, as if that wasn't enough, the whole province was still trying to recover from a massive earthquake just the month before. Just devastating. And this quote here from the governor of Cebu, Pamela Baruquatro, it just hits the nail on the head. She says they prepared for the typhoon, for the wind, for what they thought was coming. But what they got was this completely unexpected flash flood that just overwhelmed them. And that's the key takeaway here. They weren't fighting the wind. They were fighting the water. So that brings us right to the heart of the matter, the anatomy of this killer storm. Let's really get into the science of why it's not always the wind you gotta worry about. It's the water. Yeah, check this out. It really puts things in perspective. On one side, you've got Super Typhoon Ragaza. By wind speed, it was the heavy hitter of the year, no question. But then you look at Kalmaegi. It was slower, kind of lumbering along. But because it was so slow, it just had more time to unload absolutely historic amounts of rain. And that is what made it so much deadlier. And this isn't just a one-off thing. A CNN forecaster, Taylor Ward, pointed this out. He said we get so fixated on wind speed, the category of the storm. But he says water is almost always the #1 killer, whether it's from flooding like we saw here or storm surge. Okay, so where does all that catastrophic rain come from? Well, think of a typhoon as this gigantic, powerful engine. And what's its fuel? The warm water of the ocean. So let's pop the hood and see exactly how this engine works. Now, to really get into the nitty-gritty of how this works, we're actually going to look at a scientific study from 2018. It was about a different storm back in 2014, but get this, it had the same name, Kalmaegi. Total coincidence. But the physics are exactly the same, and it gives us this incredible inside look at what's going on. All right, I know what you're thinking. This looks super complex, and honestly, it is. This is straight up raw data from that study. But don't get bogged down in the details. Just focus on the big picture with me. On the left, we're looking at sea surface temperature. See all that blue popping up? That means the ocean surface got a lot colder right after the storm went by. Now look at the right. That's salinity, how salty the water is. See the warm colors getting brighter? That means the water got saltier. So what the heck does that mean? It means the storm is basically a giant blender churning up the ocean. This whole process has a name. It's called sea surface cooling. Basically, the storm's powerful winds are pulling up massive amounts of that colder, saltier water from way down deep. When that cold water mixes with the warm surface water, it creates this incredible exchange of energy. It's like pouring gasoline on a fire. All that heat and moisture gets sucked up from the ocean into the atmosphere, And that is what supercharges the storm. It's the fuel that creates the kind of record-breaking torrential rain that we saw in the Philippines. And that brings us to right now, the present danger. Because after Kalmaegi left the Philippines, it didn't just fizzle out. Oh no. It moved out over the very warm waters of the South China Sea. And that giant ocean engine we were just talking about, it fired right back up and kicked into high gear. You can see it right here on the map. The storm's projected path is taking it straight for central Vietnam. And after feeding on all that warm water, drawing all that new strength, it's become an even bigger threat than before.
Yeah, it's not just drifting along, it's actively getting stronger. The storm basically powered up over the open water, re-intensifying into the equivalent of a Category 4 hurricane. We're talking winds hitting 215 kilometers an hour. So let's be clear, Vietnam is not getting the leftovers here. They are staring down the barrel of a reloaded and frankly even more dangerous storm.
And here's what makes this situation so incredibly dire. Vietnam is about to get hit while it's already in the middle of a flooding catastrophe. I mean, the central part of the country has been getting hammered by nonstop rain for a week. 40 people have already died in those floods. Nearly 80,000 homes are already underwater. And this is going to be the 13th storm to hit Vietnam this year. It's just relentless. So, the devastation from Kalmaegi, it's about more than just this one storm. It's pulling back the curtain and forcing us to ask some really tough questions about our infrastructure. Are our cities actually built to handle these kinds of extreme weather events, which seem to be happening more and more? And if we look back at Cebu, people are demanding answers. An investigation has been launched into more than 500 flood control projects. You can see on this table, 343 of them were finished under the last administration. These projects were supposed to work, but when the deluge came, they just weren't enough, and now everything is under review. And this isn't just local frustration, it's coming from the very top. A spokesperson for the president's office basically said that President Marcos is just as angry as the governor is. They said, look, money was set aside for these projects, and when they were put to the ultimate test, it looks like they completely failed. Which really leaves us with this one big, crucial question. Look, Typhoon Kalmaegi is a heartbreaking case study for sure, but it's not an isolated incident. It's part of a bigger global trend. Storms are getting more intense, they're moving slower, and they're dumping a lot more rain. So the real question we all need to be asking ourselves is this. Are our cities, is our infrastructure, are we really ready for this new reality?